Good day, students. Welcome to math.serve.com, where we don't just solve, we teach. In this clip, we're going to be going over problem number 4 of the 2015 AP Calculus AB pre-response questions. The goal here is to go over some really cool strategies and also give you some tips and tricks that will help you to pass the upcoming exam. We're not just solving the problem as indicated in our opening statement. All right, question 4 reads, consider the differential equation dy dx equals 2x minus y, part A, on the axis provided, so this coordinate system that's provided here, sketch a slope field for the given differential equation at the 6 points indicated. Okay, so we have 6 points, 1, 2, 3, 4, 5, 6. Now what you want to recall is that a slope field is a collection of tangent lines at the indicated point. Okay, so the whole idea here is just to give you a snapshot as to how the tangent line is behaving at certain points on the coordinate system. These are the steps we're going to employ in generating our slope field. First of all, we're going to make a chart using the coordinates as a guide. Then we will then input the coordinate values and compute our slope at each of the points using the differential equation. Then we will use rise over run just to generate a snapshot of the tangent line at each point. Okay, so those are the steps we'll employ. Let's go ahead and create the chart. As you can see, I have 4 columns here. I'm going to be putting the coordinates x and y in the first two. The differential equation computation will be inserted in the third column. This will help me to calculate the value of the slope at each point. And I'll just put the slope here, the resulting answer, okay? Let's start with the first coordinate, 0, -1. So what do we do with these 2 points? We input it into the differential equation and calculate what the slope of the tangent line will be in that equation. When you're working with negatives, you want to proceed with caution. Don't forget, whenever you multiply negatives, the signs change. So we're going to have 0 plus 1 here, which is 1. Our slope at 0, -1 is 1. If I want to write it in rise over run form, this is 1 over 1, which means we're going to be rising 1 and running 1 from that point. Okay, let's move on to the second coordinate. I like to work vertically. I like to work with points on a specific x line, okay, and then move in the other direction. You can go in whichever order that you want. I like to stay organized. And a lot of times the patterns that emerge when you work horizontally or vertically, so you can exploit those patterns of symmetry that reveal themselves in a slope field. Okay, so I'm going to move right up to this point, 0, 1. So let's put that in. X is 0 and y is 1. So as we did in the first row, we are going to input these 2 values into the differential equation. 2 times 0 minus 1. When you calculate that, you have 0 minus 1, which is -1. All right, so our slope is -1 over 1. What does that mean in terms of graphing our slope? We're going to fall as opposed to rise because of the negative rise, and we'll run 1. All right, let's move on to the last point on x equals 0 line. The last point is 0, 2. X is 0, y is 2. The slope at that point, just input these coordinates into the differential equation. 2 times 0 minus 2. So we have 0 minus 2, which is -2. Okay? So what does that look like? A slope of -2, we can write it as -2 over 1. We're going to fall 2 places and run 1, starting from 0, 2. Okay, now we're going to go over to our x equals 1 collection of points, and then compute the slopes at those coordinates. So we'll start with the bottom one. We have 1, -1. So x is 1, y is -1. So we're going to compute 2 times 1 minus -1. Okay, another thing you want to be careful about when inputting these values is you want to keep track of your coordinates. Sometimes x could be first or y could be first, so ensure that you're entering your coordinates correctly. Okay, so here we have 2 plus 1, which is 3. So our slope is 3 over 1. We're going to rise 3 and run 1 starting from the point 1, negative 1. Next coordinate is at 1, 1. Let's go ahead and compute that. At 1, 1, we're going to just plug that into the differential equation as we have been doing. So we have 2 times 1 minus 1, which is 2 minus 1. Answer is 2. Actually, I'm sorry, 2 minus 1 is 1. 2 minus 1 is 1, so we'll write it in rise over run form. We're going to rise 1 and run 1 here. And then the last point is 1 comma 2. Okay. All right, let me show you the point I'm talking about right here. This point right here, 1, 2. Let's compute what the slope is at that point. 1, 2. And put it into the differential equation. We have 2 times 1 minus 2, which is 2 minus 2. Answer is 0. So we have in a fractional form 0 over 1. So in this case, you have 0 rise, so there's no rise, and you just have a run. Okay, so you're going to be having a horizontal tangent line here. Now, this is just a side point. If you have an undefined tangent line, okay, let's say you ended up with 1 over 0, how do you graph that? In this case, you have a rise with no run. This would be a vertical tangent line. Okay, so just keep that in mind. Okay, so we have all our slopes calculated. Now what we're going to do is draw the graph. Okay, now I'm using this electronic device, so it's very easy for me to draw straight lines and take advantage of the grid. But if you're doing this on the AP exam, you can exploit the coordinates provided for you here. Okay, so from 0 to negative 1, this is what you do. You have at 0, negative 1, you're rising 1, running 1, starting from this point. So all you do is place your ruler at 2 points that formulate that slope. So if I start from this point right here, I rise 1 and run 1, it takes me right there. Okay? So all you do is you make your line and then you place your ruler there and then you draw a short line. Okay? So let me show you what it's going to look like. When you place your ruler on these 2 points, you is going to have follow this pattern and then you just draw a snapshot. All you're doing is drawing a snapshot of the slope. Okay, so your ruler will be your guide. Now let's move on to 0, 1. That case, negative 1 over 1 is your slope. So starting from this point right here, you place your ruler here. If you drop 1 and run 1, your ruler should be going through this point and this point. Okay, and then when you draw your line, you just want a snapshot, so it's going to be something like this. It's just a sketch, okay? So there goes the slope of the next point. And then if you go to 2, that one we are going to be going down to, we're going to be falling to and running 1. So when you place your ruler, you just want to place your ruler so it goes through this point and that point. That's the slope of negative 2. Okay, so when you place your ruler there, you just draw a snapshot of the slope. Okay, so it should look something like, make sure this is well done, something like this. Just a tiny tangent line. Okay, all right, let's move on to the next pair of coordinates. We're going to graph the slope of 3 at this point right here. So in this case, we're going to have to add a point, okay? Because if we want to draw the slope, we're going to rise 3 and run 1. So let me see, 1, 2, 3, 4. 1, 2, 3, 4. So something like that. Okay, so that's how you place your ruler. You can just put a point in there on the exam sheet just to guide you, so you can just guesstimate where the point should be at, and then you just draw your line. Okay, so mine is going to be looking something like that. So it's just a snapshot, just a short little tangent line to give an indication of the pattern that the tangent line exhibits at that point. Okay, let's move on to the next one. At 1, 1, the slope is 1. So we are going to take advantage of this point again, rise 1, run 1, or you can drop 1 and fall back 1. Same thing, okay? Your tangent line will look like that. And then the last one, slope of 0. What do you know about the slope of a tangent line when it's 0? It's a hortan, it's a horizontal tangent line. That one's easy. You run with no rise, okay? So there goes a slope field for this problem. Okay, so how is this problem scored? In this problem, you get a total of 2 points, okay? This is how you earn your 2 points. You earn your 2 points by graphing the collection of vertical tangent lines correctly. So these collection of tangent lines at x equals 0, if you graph all these tangent lines correct, you get 1 point. And then if you graph these collection of tangent lines vertically at x equals 1 correctly, you get another point for a total of 2 points. Okay, so that's basically how this problem was scored. All right, let's take a look at the B part. We're to find the square y dx squared in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Okay, so what on earth is this? The square y dx squared. That is the second derivative, okay? So one thing you want to keep in mind, since we're talking about concavity here, is that the sign of the second derivative tells you the concavity of the function, all right? So recall that when the second derivative is positive, let me change the color here. When the second derivative is positive, then the function is concave up, all right? But when the second derivative is negative, then the function is concave down. So that's the connection we want to keep in mind. All right, so these are the steps we're going to be employing to do the problem. We're going to, first of all, find the second derivative, and then we're going to determine the sign of x and y in the specified quadrant. Then we'll determine the sign of the second derivative by following the general pattern of the sign of the x's and y's and inputting that into the second derivative. And then when we determine the sign, then we can determine the concavity. And then step number 4, which is really important, we want to give a reason for our conclusion. Okay? All right, let's go ahead and start. We have the first derivative given by dy dx equals 2x minus y. So we're going to differentiate implicitly here. This is an implicit differentiation process because if you know this right side is in terms of x and y. It's not explicit in terms of just one variable. So we are finding ddx. ddx just simply means differentiate with respect to x. Whenever you're differentiating implicitly, you want to pay close attention to agreement. Okay, what you're differentiating with respect to doesn't match the variable. If there's a mismatch, you want to add d of that variable d what you're differentiating with respect to. In this case, when you're differentiating the y's, you would differentiate the y and append dy dx to the result. That's the chain rule. Okay. Now on the left side, d dx of the y dx means when you differentiate the first derivative, and the notation there is simply d square y is d square y, dx times dx is dy squared. I'm sorry, dx squared, okay? So this just means second derivative, that's what it means. On the right side, let's go ahead and differentiate implicitly. When you differentiate 2 times x, factor out the 2. If you differentiate x, you have 1. dx, we have agreement there, they cancel out, okay? Minus, if you differentiate y, you have 1. Just as you differentiated x, you have 1. Because if you use a power rule, there's no agreement, so you have to append dy dx. Don't forget this. This is very important. Okay? Now we have d square y dx squared equals 2 minus dy dx. So the question now is, are we done? Is this the second derivative that the problem was asking us to find? The answer is no. The problem asks us to find the second derivative in terms of x and y, and this is in terms of the y dx. So how do we make our answer consistent with what's expected of us here? We're going to use the first derivative to make a substitution, okay? So we're going to make a substitution here, take out that dy dx and replace it with what is equal to, we have d square y dx square equals 2 minus, take out the y dx and plug in what it is equal to, which is 2x minus y, like that. And then we're going to distribute. Now, whenever you have a minus and carrying out the substitution, you want to proceed with caution because minus inverts signs. Okay? So final answer, d square y dx square is equal to 2 minus 2x plus y. Okay? Now, a good practice to carry out during the AP exam is boxing your final answers. Okay, it really helps the grader to zero in on your final result so that it's easy for them to give you appropriate credit. You might have made a mistake somewhere else, but when you have your answer boxed in, they can know exactly where your final result is. So boxing your answers is a very good practice. Now we found the second derivative. We're moving on to determine the determination of the concavity. Okay, so we're focusing on just quadrant 2. What do we know about x and y in quadrant 2? If you draw a coordinate system, okay, this is positive x, this is negative x, this is positive y. So in quadrant number 2, x is negative, y is positive. Okay, so let's go ahead and write that down. In quadrant 2, x is less than 0 and y is greater than 0. So how does this impact the sign of the second derivative? So the square y, the x square, is going to become 2 minus 2 times. For every x in the second quadrant, we know is going to be a negative number that will be inputted here. So we're going to put minus, okay, is a negative number, plus the y substitution, y is always going to be positive in quadrant 2, okay? Remember, all we care about is the sign of the second derivative. We don't care about the numerical value, okay? Is it positive or negative? That's what tells us the concavity. So the question is, what is the sign of this result, okay? So this is how we're going to do it. 2 is always positive, so we have a positive number. Minus times minus, you take them, the negative of a negative number, you have the opposite, so it's going to be plus a positive number. Minus times minus is plus, plus a positive number. What's happening here? We're adding 3 positive numbers. So the final sign of the result will always be positive in quadrant 2. Okay, so we can simply say that d square y dx is what? D square y dx square is greater than 0, it's positive. So what does that tell us? When the second derivative is positive, our graph is going to be concave up. Okay, so let's go ahead and write down the conclusion. Since d square y dx square is greater than 0 in quadrant 2, all the solution curves, remember the solution to a differential equation is the function, okay? So all the solution curves are or will be concave up, concave up. Okay, whenever they ask you to give a reason, you have to just put everything together in a nice little sentence and you will get your full credit. Okay, so how do you get scored in this problem? This problem is worth 2 points. on the scoring guidelines. You earn the first point by accurately finding the second derivative, and you earn the second point by stating the conclusion and the reason for why you wrote what you wrote. Okay, so you um, state that the second derivative is greater than 0, which means that the solutions are concave up. So this statement here earns you the second point, and then the second derivative computation earns you the first point for a total of 2 points. Okay, let's take a look at the C part. It says let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Question, does f have a relative mean, a relative max, or neither at x equals 2? Justify your answer. All right. Now we are asked to provide justification here, so we want to be careful to tie everything together once we are done. Now, recall what the second derivative test is. That's the fastest way of determining the nature of the extrema at a point if you are provided with the first derivative. Okay? So the second derivative test goes this way. If the if the first derivative is equal to 0 at a point, that makes it a critical point, and the second derivative is greater than 0, then you have a local minimum. What does that look like? Well, if you have upward facing, if you have a second derivative that's greater than 0, so it's concave up right there. And at this point, you have a horizontal tangent line, so the first derivative is going to be 0. So you have concave up, second derivative greater than 0, first derivative is equal to 0. This extrema is a local min. That was the whole idea of the first part of the second derivative test. And for the second one, second derivative is less than 0, concave down, and the point where the first derivative is 0, you have a critical point, then in this case, we have a local max. Okay? All right. So these are the steps we're going to employ. We're given a point right here. The point can be extracted from this equation. This is your x, your input, your independent variable. This is your output, the y. So the point is 2, 3. So first thing to do is we want to ensure that we have a critical point here. If it checks the test for the critical point, then we'll proceed to determine the sign of f double, which will tell us if it's a max or a min. All right. So let's do the test, verify that f prime of 2 is equal to 0. Okay, so what we're going to do is we're going to call up the differential equation. This is f prime dy dx. We know that dy dx is 2x minus y. Okay, now we're going to evaluate the derivative at that point. So what is dy dx evaluated at 2, 3? So just simply plug them in here. If we get 0, then we know it's a critical point. Okay, if not, then we have a problem. So we have 2 times 2 minus 3. That's 4 minus 3, which is equal to 1. Uh-oh. This is not equal to 0. 2, 3 is not a critical point, so it's neither a relative max nor a relative min. So the answer is neither in this case. Okay, so we have to write a statement. We have to justify our answer. So this is what we will say. At x equals 2, we do not have an extrema. Because the y dx is not equal to 0. Okay, so we have the y dx is not equal to 0, hence it is not a critical point. It is not. No, it is not a max or min. All right. So that's the justification there. Okay. Oh, I forgot to go over the scoring guidelines here. Oh, for this part, the C part, you earn a total of 2 points. Okay, the first point is determined by finding what the first derivative is, namely it's verifying that this is if this is a critical point or not. So if you find the first derivative at 2, 3, you earn a point. The second derivative is providing your justification, okay, and the conclusion. So what's your final answer? Is it max, min, neither with a justification? So we stated max, min, and we said that the reason is because the first derivative is not equal to 0. So just putting those two in a nice little sentence will earn you your second point and for a total of 2 points for the C part. Okay, let's take a look at the last question. Part D, it says, find the values of the constant m and b for which y equals mx plus b is a solution to the differential equation. Now, one thing you want to remember is that the slope of a line, m, is the derivative at that point, okay? So these are the steps we're going to use to solve this problem. First of all, we're going to express the equation in y equals mx plus b form. And then we're going to set the slope equal to m and then solve it. Okay? So I made a statement earlier that the slope m is the derivative at that point for a line. Okay, you got to be careful with dealing with a line here. So how do I know that that's the case? Well, check this out. If we have the point slope form of the equation of a line, what is the derivative of this equation? If you differentiate with respect to x, d dx of this equation, the derivative dy dx is equal to m plus 0. So you see what I was saying earlier that for a line, the derivative is m. Okay, so we're going to be taking advantage of this fact as we solve the problem. So we have a differential equation. This is, think about solving systems of equations, okay? So let's say this is equation 1. Now we have to come up with a second equation, which is a differential equation. Differential equation dy dx is equal to 2x minus y. All right. So you can't do any, well, you can eliminate if you want, but we can just do straight up substitution. Okay. So since dy dx is m, dy dx is 2x minus y, we can substitute m for dy dx in the second equation. So substitute m for dy dx in the second equation. So we have m equals 2x minus y. Okay, so to finish this problem off, it's pretty easy. We just get y by itself, the coefficient of x is m, and then the other term is b. Okay, so to do that, we can just simply just add y to both sides and subtract m. Okay, if we do that, that yields y, scroll down a little bit, y, these m's cancel out, equals y equals 2x. Let me color code this so it's easy to see what I'm trying to do. 2x minus m. Okay? All right, so this is the slope-intercept form of the equation of the solution. Okay? So what is the slope and what is the y-intercept? Okay, we asked to find m and b. All we just do is write down the slope-intercept form of the equation of a line. We know that y is equal to mx plus b. So what does this tell us? It simply tells us that the coefficient of x2 is m, and negative m is what? B. Okay? So just match them up like that, and then it kind of makes sense what we're about to do. So we have the first solution that's easy to determine. M is equal to 2. Okay, but B is negative m. But we already know that m is 2, right? So we can just plug that in here. This follows that b is -2. Bam. All right, so there goes your answers. M is equal to 2 and B is equal to -2. Okay, so scoring guidelines. Before I do that, let me box my answer. That's a good practice. Bam. So scoring guidelines. You get this question will earn you 3 points. Okay. The first point is in differentiating y equals mx plus b and getting this equation right here. That earns you a point. 1 point there. Second point, by setting the slope equal to, setting m equals to 2x minus y, that earns you another point. Substitution in your system of equations, so that earns you another point. And then stating your final answer clearly will earn you another point for a total of 3 in this problem. Thank you so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for updates to the remainder of this review series. If you have any questions about what we went over today, or any problems on the AP Calc exam in general, just place your question in the comment section below and we'll be glad to assist you. More clips can be found on mathgoserve.com under AP Calculus. Thanks again for watching and have a wonderful